Good afternoon. This is Scott Helms, Vice President of Technology here at ZCorum. And today I wanted to talk about leveraging full spectrum capture for remote spectrum analysis using the new generation of DOCSIS chips. We've long been able to do various types of monitoring on the DOCSIS plant, especially on the upstream side. The downstream has been more of a challenge because we don't have that one point of collection that we do on the upstream side. This screen is kind of illustrating the idea that on the upstream, all of the traffic gets concentrated in the head end or the CMTS, whereas on the downstream side, we're really dealing with everything out in the plant. And that's made it very difficult to try and get a cohesive monitoring solution out that allows us to see the conditions of the plant in many different places. One approach that we don't really recommend is using your customers as probes. Unfortunately, this is kind of the default position in a lot of cases because it doesn't really cost us any extra capital or resources to go do, though it certainly can cost us revenue if we keep doing that. One particular solution that people have tried to use to monitor on the forward path has been to put probes out in the network. And probes are, in a lot of cases, a good solution, but they do have limitations in that they can only see the impairments that are around them. So in other words, you can't see an impairment that's behind a probe that doesn't, on the downstream side, that doesn't allow us to pick up that impairment in a monitoring system. The other problem, of course, with probes is that they tend to be pretty expensive, and the more granular you want to be able to monitor and the more thoroughly you want to be able to see your system, that means the more physical equipment that you have to put out into the plant and maintain over time. SNMP monitoring, primarily with, I guess, the cable modems and also with the set-top boxes, is also an option. And in this example, what we're seeing is the fact that you have to actually be on the channel that the set-top box is tuned to in order to catch that impairment. In this case, we actually have an impairment on channel 7, but and it's affecting all of those houses that are red, but only one of those set-top boxes is actually tuned to that channel, so it sees that problem. And that's one of the major limitations of trying to use the set-top boxes. And of course, that's assuming that you already have two-way communication and you are actively monitoring your set-top boxes with SNMP. What we really want to try and do differently is to actually use the remote downstream analysis capabilities in the new DOCSIS chips to be able to see the entire spectrum. In other words, I can use a cable modem or a set-top box that has this capacity to see all of the downstreams as they are being received in that home, which means I don't have to wait until the customer is actually using that QAM before I can see if it's impaired or not. And that's a significant advantage over some of the earlier approaches. This is just an example using the same one that we were doing earlier with the SNMP monitoring, where we can now see that impairment exists in all of those homes because we don't have to wait until the set-top box or the modem is actually trying to use that channel before we can see the problem with it. Another issue with normal spectrum analysis, as illustrated by our technician here, is that in a lot of cases our ability to put tools into our technicians' hands is limited by our budgets, and that's almost always the case. So one of the issues that you run into, of course, is I'm going to put out tools for my workers to use, but sometimes those things break. Sometimes they have to be upgraded to the latest technology. And of course, we have to train people to be able to use them effectively. All of those things can be real challenges when we start dealing with large numbers of technicians and trying to diagnose things in an accurate manner. One other thing that people don't think about in a lot of cases is if this is a normal signal meter, then we also probably need to worry about calibration over time. So our maintenance costs are something that we have to deal with periodically on any kind of gear if it's going to be accurate. Here we're kind of highlighting the idea that training is not always the easiest thing to do when we're talking about spectrum analyzers. One of the things that's happened as younger generations of workers have begun moving into our workforce, one of the things we see is that they're not quite as comfortable with traditional spectrum analyzers as some of the people who came before were. Part of that has just been what they've been exposed to. Your average college graduate is going to have spent much less time in front of an oscilloscope or spectrum analyzer, even if they came out of an engineering degree, than was true in years past. And so one of the things that we've tried to do at ZCorum is try and create tool sets that have interfaces that are going to be comfortable for younger technicians to use, whereas they might be intimidated when you put them in front of a normal spectrum analyzer. If you hand them that same kind of information on an iPad or other kind of tablet, then they really are very comfortable trying to work with it. This is definitely a key point. One of the things that we all struggle with is the cost of getting from point A to point B. I can't count the number of times that I've actually had to just get into a truck and drive 20 miles purely to take a spectrum measurement, just so I could see exactly how the signal was being received at that point. It's much more convenient, much less expensive to be able to take that same measurement from a remote piece of CPE gear that'll give me the same information without having to leave the head end or leave my office. And obviously I'm not dealing with gas costs or wear and tear on vehicles as I'm trying to make that measurement. And this ties directly into that same idea of being faster and being more efficient. Now I can avoid the time that it takes to drive out to a spot. But the other thing that's happening is as the number of devices that support full band capture increases in our cable plants, we really get the ability to do something pretty special that we've never been able to do before. Let's just assume for a moment I've got a customer who's got relatively new set-top boxes and an up-to-date cable modem, all of which support full band capture. If that customer calls in and they say, well, I have a problem receiving a specific signal, then all we really have to do is start tracking down, what channel is that on and where are they having problems seeing that signal. And we can actually see the spectrum, see the QAM that's carrying that channel from multiple points inside that customer's home without ever having to leave, in this case, the desk. And that's a particularly powerful use of this technology. You can imagine seeing exactly what the spectrum looks like to the upstairs bedroom set-top box, which is where they're actually having the problem, and comparing that to what it looks like in the other parts of the house. It makes it very easy to figure out, oh, this is an in-home wiring problem, probably take me directly to the piece of cable that has the issue, versus this is a problem that's affecting everything in the home. And this is just a look at what the interface looks like. So we can see we're looking at 5 haystacks here, 5 QAMs that are being sent out. These are all video QAMs just by happenstance. But we can see exactly what everything looks like in real time on a tablet or PC interface. And that's all I had for today. And thank everybody for paying attention. And hopefully we can talk to you about remote spectrum analyzing soon. Thank you.